Hey mathematicians, this is Mrs. Steele. In this video, we're going to discuss how we know when an expression is fully simplified. Now to get started, I want you to brainstorm a little bit. I have an expression here that is not fully simplified. So brainstorm maybe a quick little checklist of what would you put here? How do you know when an expression is fully simplified? Please pause me, brainstorm, and then come back. Welcome back. What I'm going to do now is share with you my list of the things I think about. I have a checklist of 4 items of how do I know when an expression is fully simplified. And then we can compare it to your list. The first thing I look at is an expression is fully simplified when there are no grouping symbols. And the most basic grouping symbols that we're going to come across are parentheses or maybe brackets. There are others that we'll see, but those are probably the 2 most common. The second thing, we can almost even think of this as a little checklist, is expressions are fully simplified when all arithmetic has been performed. So if you have numbers that are being added, subtracted, raised to powers, you do all that arithmetic. Next thing, expressions are fully simplified when all your like terms have been combined. Make a little checklist item, all like terms combined. Before we continue with our list, I want to just talk briefly about like terms. First of all, because that word term, it means they're things that are being added. We're going to see lots of different types of like terms this year. Right now we're focusing on variable terms, and variable terms are like terms if they have the exact same variable. Here are some cases of things that are like terms, 3x and 6x. They both have an x. 3x squared and 6x squared. Their variables are both x squared. Here are some no cases, 3x and 6x squared. They both have an x, but notice the 3x has x to the first power and the 6x squared is x squared. The variable must be exactly the same. And lastly, here's another no case. Both these terms have an x, but the 6xy has an extra y. So just a quick little thing about like terms. Then finally, if we're going back to thinking about it, and expressions are fully simplified when the last thing is there are no double signs. And I'll just give a quick example for this. If we had something like 3x plus -2, notice we have 2 signs right together, which can lead to a lot of confusion. Here, adding a negative number is the same as subtracting. So this would be the same as 3x minus 2, and we no longer have a double sign. All right, so there's my checklist of things I go through when I simplify expression. Pause me and compare this to your brainstorming. See, are there other things you were thinking about, or did your list sync up with mine? All right, the last thing we're going to do in this video is just kind of work through the checklist to simplify this example expression. The first thing I'm going to look at is it's fully simplified if there are no grouping symbols. But here I see parentheses, and we have a great tool for undoing those parentheses, and that's the distributive property where we can distribute multiplication over addition inside parentheses. So this stays the same. And when we distribute, we have 2 x's plus 2 times 8, which is 16. Great. No grouping symbols. The other thing we're going to look at now is their arithmetic to perform. And I see I have a -2 here, adding to a 16 here. One thing I like to do sometimes, this is mathematician's choice, is rewrite subtraction as the addition of the opposite. One thing I like about having everything in addition is that you can move your terms around and you can add in any order. So now I'll say I have a -2 plus that 16, which gives me 14. So I have -6x plus 2x plus 14. Great, check. Next thing on my list is, are all like terms combined? Well, I've got a couple like terms here. They both have an x as their variable, and negative 6x plus 2x, negative 6 plus 2, negative 4x plus 14. Check. And then lastly, do I have any double signs? I don't. So we've got the fully simplified expression. All right, mathematicians, I hope you found this helpful. It's a great little checklist of knowing when an expression is fully simplified, and then we work through an example of simplifying an expression. We'll be doing a lot of this in class, so I'll see you soon.